Let's see alcohols now. So alcohols will undergo complete combustion in plentiful supply of oxygen and is going to produce carbon dioxide and water. Should be able to write the balanced chemical equation for any for the combustion, for complete combustion of any alcohol. So it gives carbon dioxide and water. So you balance carbon first, then you balance the hydrogen, and at last you balance the oxygen. Do not forget that you have one oxygen here. So there's 7 oxygen, so 3 times 2, 6 oxygen plus 1 here. So that's 7 oxygen in all. And as you can see here, alkanes and alcohols can both be used as fuels. They both give large amount of energy. However, the corresponding alkane is going to give more energy than the corresponding alcohol, because the alcohol already has an oxygen here, so it's already partially oxidized as compared to the corresponding alkane. So the corresponding alkane would be C2H6. The alcohol is C2H5OH, so there's already an O here, so it's already partially oxidized. That's why it's going to give out less energy. Alcohols are going to be oxidized. They can be oxidized by oxidizing agents such as potassium dichromate or acidified potassium manganate. So these are the 2 oxidizing agents that you should know. And we can oxidize primary and secondary alcohols. So this is the half equation for the oxidation for the use of potassium dichromate. So this is actually a reduction reaction because this is an oxidizing agent, therefore it is itself going to be reduced. So this is a reduction reaction. You have the half equation here, and during this reaction you'll have a color change from orange to green. With acidified potassium manganate, this is the half equation, so you'll have color change from purple to colorless. You need to know the color changes. Now, the type of product that we're going to get from the oxidation will depend on the alcohol being used. Now, a primary alcohol can be reduced into 2 different molecules. So the primary alcohol can either be reduced to an aldehyde. So this is a first step where you have formation of 1 double bond O, aldehyde. And this can be further reduced, can be further oxidized to a carboxylic acid. So oxidation of a primary alcohol can occur in 2 steps. So this step is going to be a mild oxidation. So if you use a mild oxidizing agent, for example, potassium dichromate 6, you're going to have the oxidation in a stepwise manner. So you're going to get the aldehyde, and then if you keep oxidizing, you're going to get the carboxylic acid. But if you use a strong oxidizing agent like potassium manganate 7, you're going to oxidize the alcohol directly carboxylic acid. So then you're not going to get an aldehyde. So if you want to get an aldehyde, you have to oxidize using potassium dichromate 6 only. But if you want to get a carboxylic acid, you can directly oxidize using potassium manganate 7 or excess of potassium dichromate 6. Here. So these are the 2 types of oxidation that can occur with a primary alcohol. So if you need aldehyde as the product, you're going to use acidified potassium dichromate, and you're going to recover the aldehyde through distillation to prevent any further oxidation. But if you need the carboxylic acid, you're going to use a strong oxidizing agent, KMNO4, or you can use excess of potassium dichromate 6. So here you have the setup where you have the distillation. So you have the ethanol, so you have the alcohol, ethanol with acidified potassium dichromate 6 mixture. So here you have the oxidation that will happen, and you have the distillation of the aldehyde. So ethanol is going to be collected here, corresponding aldehyde. The aldehyde has a lower boiling point than the carboxylic acid. Why? So if you look at the structure, ethanol and ethanoic acid, what can you deduce in terms of bonding? So boiling point will have to do with forces of attraction. So ethanol, you can see there's just the O here, but ethanoic acid, you have OH, so which means that you're going to have hydrogen bonds here. So hydrogen bonds means that you're going to have stronger intermolecular forces of attraction. So in the aldehydes, you're going to have the weak dipole-dipole forces only, while in the carboxylic acid, you're going to have the hydrogen bond, therefore strong intermolecular forces of attraction between the molecules. So this explains the boiling point. And like I've mentioned before, if you need carboxylic acid, you use acidified potassium manganate 7. The aldehyde must remain in the reaction mixture with the oxidizing agent. Therefore, the mixture is going to be heated under reflux. Heating under reflux is using a condenser, like here. So you have the reaction mixture over here, you have a condenser on top. This condenser is going to, if ever you have any vapors of the reaction mixture that is going to be produced, the vapor is not going to escape. So vapor is going to condense back into the reaction mixture. So for example, if you have the aldehyde being produced as a vapor, the aldehyde is going to condense back into the mixture and further react to give the carboxylic acid. So heating under reflux is a technique used to prevent the escape of volatile organic compounds so that they undergo complete reactions. Okay. Now, secondary alcohols will also undergo oxidation, and it's going to be oxidized to ketones. There's just only one step of oxidation for secondary alcohols because there is no other possibility of oxidation. So, for example, propanol here, so propane, and then the OH is on the second carbon. So propanol is acidified by potassium dichromate 6 to form propanon. So propanon, you're going to have a double bond O here. So this is propanon, and there is no other possible oxidation. You cannot add an O anywhere else. So that's the maximum oxidation. So you have already oxidized this bond, this hydrogen. There is no further hydrogen attached to this carbon, so you cannot further oxidize. So propanol forms propanon here. So you can use this to show oxidation, or you might also have to write the equation with the half equation of potassium dichromate. The next reaction is the condensation reaction to form an ester. So this is also called esterification. We have already covered the naming of esters, so you should know how to name esters using the alcohol and the carboxylic acid. So esters are used as flavoring agents. They have that sweet smell. They are used as medications, solvents, explosives. And esterification is a reversible process. And normally what happens is you have a carboxylic acid that will react with an alcohol in the presence of concentrated sulfuric acid to produce ester and water. So for example, propanoic acid plus methanol. So you're going to get the ester. When you name the ester, you always start with the name of the alcohol first and then the carboxylic acid salt. So alcohol is methyl and the carboxylic acid salt is propanoate. So methyl propanoate. And then you're going to have water. Let's draw the product. So you have the propanoic acid and then you have methanol. And when you're forming the ester bond, so you're going to have the removal of water. So here you have water that is being removed. Therefore, this carbon now is bonded to this oxygen. Not sure the arrow. The arrow does not mean that it's not a mechanism. It's just showing that this carbon is now linked to this oxygen. So this is the propanoic acid part and this is the alcohol part. And here, this is called the ester linkage over here. And then you're going to have water as the product as well. So this is methyl propanoate. Try to draw for this one and then you can check your answer. So here you have ethanoic acid with ethanol giving ethyl ethanoate. This is a reversible reaction. So I've included the reversible arrow everywhere with H plus showing that you need the sulfuric acid. So sulfuric acid is a dehydrating agent. It removes water, but in the presence of acid, the ester linkage can also be broken, giving you back the carboxylic acid and the alcohol. So with this we end with alcohol's reactions. So this is a recap of the reactions of alcohol. They undergo combustion, they undergo oxidation. Primary alcohol will give you aldehyde or carboxylic acid depending on the oxidizing agent and conditions that you're using. Secondary alcohol will give you a ketone, but you have to heat under reflux. And you also have the esterification reaction where the alcohol react with the carboxylic acid to produce ester and water. This is a reversible reaction in the presence of sulfuric acid.